It's day 2 with the T24, and this is the rear axle. It has a, I'll show you how this is. It has a drive shaft that has 4 splines on it, which is great because with the 4 splines you can put a Phillips screwdriver in there and activate the drive shaft. You can spin it freely or whatever you want to do. So I've got a small screwdriver, and this is the rear of the truck, and it spins just fine. That's free, no problem there, easy to turn. Well, with the symmetrical suspension links, I should be able to do the same thing on the front, and I can, but this side for some reason has a ton of resistance, and I don't know why. So I'm gonna pull the, I can feel something chunking in there. So I'm gonna pull the axle apart and find out what's actually happening. While I have this apart, I'm gonna figure out why this thing has so much resistance to articulation. I really have no clue, other than if the ball joints are hinges rather than a ball. I mean, that could do it, but I'm not sure. I'll just pull the whole front suspension off. Well, that is the ball joint, and I'm going to see if the SCX24 ones that are plastic, that I can cut those little ears off of it, won't fit in there a little better and allow the links to twist, because I feel like even though there's a ball there, it's acting like a hinge because the sides of the link they don't have any play in order to move along the side of those little ears. This is a trick I do on my SCX24s because right out of the box they don't articulate properly either, and a lot of it is because the ball joints don't move. So what I do is I'll pop the whole thing out, and in this case I'm just going to cut off that little ear that sticks out, because the rotation of that ball is negatively affected when it hits the side of the link here. So I just chop them off and they work so much better. I'll also pop it out here because I can a lot of times get a cleaner. Oh crap, I almost lost it. Sorry. But it's got that ear on it, and just by cutting that ear off, yeah, it'll make the front end not quite as tight as far as the suspension links being located left to right, but it doesn't matter. It's a crawler. Loose tolerances are totally fine when it comes to crawling. You're not worried about it's not a race car. With a race car you need tighter tolerances, and you cannot tolerate things that are sloppy because you're on the edge all the time at high speed. I'm gonna pop this SCX24 one in there. It doesn't really stick hard, but does it have to? Probably not. So let me stick I'll put it back on the car, and well, I could just flip it around. But anyway, the ball joint is in there. It's kind of loose. It may easily come out as well, and it does. So that's not an option. I may end up just getting my Dremel tool out and cutting the ears off of this ball joint. They're not necessary, and I think it will articulate a lot more freely if those things aren't hitting the edges of the control link right there and stopping. One thing they did do right, in my opinion, is if you look at an SCX24 link, if I can find it, stand by. Alright, this is one from an SCX24, and you'll notice that the corners of this thing are at right angles. They did not round it at all. If you want your crawler to do really well, you have to round those out, because when they get into the channel that it's, when you put it in there, let me see, suppose my hand is the skid plate. When it goes in like this, if it has right angles, it can't pivot because it only has so much room. So if you round it and make it a ball, then it can spin. Well, one of the things I'm looking at here is they did it right. I feel like those are tapered a bit more than the SCX24 ones. It's not quite as sharp. Maybe a little bit sharp, but nothing like a fingernail file can't take care of. But I'm going to round those a little bit. I just think that what we're seeing here is too much restriction on the movement of those ball joints. This thing here, this one's still in it, and it's like solid. It's like a hinge. It doesn't really want to pivot that well, and even when it does, it's tight. So I'm going to cut the ears off of it. What do I have to lose? Nothing. I guess I could lose the whole ball joint, and I don't have any extra parts of these, so I'll figure out how to do it in a way that I don't lose the part. Right now I've removed completely the lower links, and all that is holding this front suspension on is the upper links and the springs, and there's still a lot of resistance to movement on that. It's better, but it's still pretty heavy. And in order to articulate, I'm actually twisting these, and I'm going to show you where these aren't moving. You will notice as I bend these that this joint and this joint have no movement at all. That is an area where this can be greatly improved. But there's no motion on that ball joint. It's great that they added metal ball joints, but if they don't move, then that's an area where they can be corrected. I'm twisting this, and those links don't move. They're so stiff. Oh my gosh. That right there is why these things don't bend. Why they don't articulate. That's a screw-in ball joint there, so that's encouraging. And I can do something with that. What I'll probably do is a mini Z trick where I actually spin that and polish down the ball itself until it fits into the cup properly with no slop but no resistance either. You gotta know when to quit. Those are stiff. That is unbelievably stiff. There's no way that would articulate. Springs might not be too strong after all. It might be this thing right here. I've unhooked the top shocks, the shock off the mount. I screwed it back in so I won't lose those parts. But I'm going to show you what I'm going to do with this particular hole here. I do want some pivot on that, but as it is, it will not currently allow me to do that. I don't need much, but I want some. And I'll show you how to take a hinge and make it a pivot. This might be a confusing drawing, but you got your hinge pin through the middle and the surrounding material. This is like the top of the shock. Okay, well, when you have a thing like this is my engineering drawing, but this is the sleeve that a pin would go through, and you can see there's no room for it to move there. I'll show you how the sleeve can be different. If I take the my reamer tool out and just remove this triangle here, a triangle here, a triangle here, a triangle here, this can now have some motion up and down. This is the tool I'm going to use. It's a body reamer, but it when I put it through this side, I can actually open that hole a little bit on the side here, and then later I'll come back through the other side and open it on the other side, and it'll kind of meet in the middle and give it enough pivot play that it should be able to articulate just fine. At least the shock can. This suspension link on the bottom is another story. I ended up using my razor knife because it's faster, but by cutting some conical holes in that, it now has some pivot. That's so long as I don't crank the screw down too far, because that'll turn into a hinge again. You can see that pivot. That's nice. That's what I wanted. There's still no play vertically, and if there was even a little bit, it's fine. It would not bother it at all. And just to show you that it does work, I'll go to the other side and show you the side I have not touched. This is a zero cost upgrade, and if I try to do the same thing here, it doesn't have any real pivot at all, just maybe a tiny, see that? It doesn't even move. So what I'll do here is just put my razor knife in the side. I'll do it right on camera for you to see, but this is going to help free up the entire chassis once everything else is right. You don't have to do much, just a little bit here to make that opening cone shaped instead of cylinder shaped. Now I'll flip it around, hit the other side. This is something that could have just as easily been done at the factory. Spin that around. Okay. I'll get my shock mount out again and we'll test fit it, see how it does. Put that through, and look at that. It has the motion it needs, and again, as long as you don't over tighten it, that's probably all the arc rotation it needs to not side load the shock cylinder and allow for free movement. So simple things. I'm not an engineer, but I know how to do stuff. I've had almost 50 years of fixing things. I started doing it probably when I was 3 or 4 years old. I'd fix stuff for the family. But anyway, not hard. None of this is hard. It just needs done. Well, does it need done? It's a toy truck. Maybe not. I take things way too serious. Part of being obsessive. And just don't lose the pieces. I've told you that many times. Save all the pieces. And one of the best ways to save all the pieces is just put them right back in where they came from when they're there when you need to hook them back up. Alright, that's quite a tangent from pulling the axle out, but needed done, so I did it. This is the upper ball joint, and when I see things like this, it makes me happy because this is a quality part. I'll show you the thing that doesn't make me happy though. If I put my screwdriver in there, it's kind of a heavy screwdriver. I mean, it can, if I do it real smooth, it's got so much friction, it'll actually stick for a bit before it drops. The nice thing is, I can probably, well, I know I can. I'm going to put my, I have a 1.5 bit, and I'm going to put it in a drill, and I'm going to spin this thing, maybe even put some toothpaste on it, and let it work into that hole so that it's more free. But that has a lot of resistance. It's billed as a ball joint. It should be a ball joint. It is a ball joint, but it's so tight that it just can't let anything move. The diff covers are also 1.3 millimeter, and what I'm going to do is just pull the top part off so I can free the servo from the diff. I want it separate from the axle. Yeah, it's a lot of work. Is it worth it? No. But it's fun. This is a challenge. It's just something to do during the middle of the winter when nothing is going on. And somebody might benefit from seeing how to do this. So pull those two top screws off, and that carrier should come right off. That looks suspiciously like an SCX24 carrier. So here's one of the problems with just direct swapping this into an SCX24. The shock mounts, somebody needs to make a block, and fortunately there's a ridge there, so you can have it indexed to stay vertical, but we just need a place to mount the shock. Also, this has a different attachment point that you've seen in the other video previous to this. And something I'm noticing here, this goes in and out as it rotates. See that? It's missing something inside. I don't know if it's a bushing or a shim. Some kind of spacer should be there and it's not. And that's probably the whole issue with this particular axle. But you can feel the resistance. I think I'm going to start by pulling the left side portal off and just pulling the guts out of it, and the right side portal, and see if that doesn't free it up. Oh my gosh, this is too stiff as well. That should drop. You wonder why your steering silvers are burning out? This is why right here. That should not push back. Watch it go up. That's a real problem. Goodness. This is why people are losing steering servos. This side doesn't do it, but it's a little chunky. The screw isn't even all the way down. Neither is this one. So we'll have to figure out what is causing that. Because if I push that up, it should fall on its own. It should not stay in position. It certainly shouldn't spring back. Next thing I'll do is just open up the diff, and we'll count the gears. If it has 16, it's the same ratio as an SCX24. If it has 14, it's the same ratio as an overdrive gear. We'll find out. This is a Phillips screwdriver, and these are long screws. Don't lose them. Okay, now I can pull that end yoke off, and you can see that it's vastly different shape than an SCX24's, and that's much bigger. That input. Oh, while this is off, I'm going to, you know what? I might have just figured this out. I'm going to pull this out. This is the worm gear, and I'm going to shove an SCX24 worm gear in there and see how it fits. Well, this is the difference between the worm gears. This is the one from the T24, and this is the SCX24, and they have a different shaft diameter, and maybe that's more easily visible from the top. The Panda's is a lot thicker, but they appear to have somebody's being cheeky here. They have opposite threads, so this is why you have to put your controller in reverse in order to go forward. So if you want to swap this out, you probably can. The difference would be you have to replace that bushing in there with one that can accept this shaft. If I put that in there, I'm sure it'll go in. Yep, goes in. but it's not right. It's got all that play. So it's not a direct fit. I pulled these 4 screws out, and I can now disassemble the axle. This is why you'll be able to run with a 4-wheel steer if you want to, because the outer part is what makes it a front or a rear axle. And let's just find out if the spur gears have the same size hole. This is from an SCX-24. Fits right on. Look at that. Pretty nice. Should be able to put the other one in there. So if we want to, we can run the SCX-24, but you'll go right to SCX-24 gearing, and you'll have to change out this main bushing here. I don't know what that outer diameter is. These should be bearings as well. That's sad that they're not. Easily done though. I believe these are the same size bearings that Mini Z's use, and they appear to be magnetic. I'm not even thinking those are necessarily brass. They look brass, but I don't know. Maybe brass is magnetic. I didn't know that. Maybe it isn't. But that right there, this is where the power goes from the motor to the axles. I mean, it transfers right there. So you kind of want this part here to be good. And if I have some extra bearings, I'm going to throw them in. This is the left side portal, and I can spin that freely. So I don't believe there's any serious binding happening in the portal itself. From the sound of it though, it's very dry. So it doesn't like being turned from the wrong direction, but it's definitely dry and would benefit from some light grease. So while I'm in here doing this, it's going to get some. This is the difference between the SCX-24 diff gear and the T24. And I'm going to count the teeth. I know that the SCX-24 has 16 teeth on it. Let's count the portal one, or the portal one. We'll call it that. Well, it turns out these both have 16 teeth on them, and no surprise by that, because the T24 one looks bigger. They're just more widely spaced apart. I'm going to get my calipers and find out what the size difference is. I'll zero the calipers and make some room here. That is zeroed, and let's find out. First we'll start off with the SCX-24 ones, and those come in at, I would like to do millimeters, 12.1 millimeters. This is the T24. Missed it. 12.8. So it's a ½ millimeter larger, roughly, a little more than that. But it's noticeable. You can see it. I kind of want to measure the side to side as well. 4.5 wide at the widest point. 4.7 at the widest point. So they're pretty close. One thing that I wish was not true is these have a slightly different angle on them. You can see the one on the right is inclined like this. The one on the left has the teeth inclined like that. I would have been real tempted to throw this SCX-24 one in there. And it does not matter which direction you turn it. it's going to still be lined up wrong. But I really wanted to just put it in there and be done with it. Have a piece that works. But it's not going to happen. I have to use this piece. Although I'm not really a fan of bushings, these seem to work pretty good. I put both bushings on both axle halves. This is obviously, these two would be inside of the diff on either side of this when it comes through. That's how those bearings go in there, and they just are gonna slide on that within these collars. So I've determined that these are free. The bearings or the bushings work fairly smoothly. They're not ball bearings, but so what at this point. The Enduro 24 has bushings as well, and they kind of work, so not too worried about it. Anyway, what that leaves is the interface between this big old gear here, I don't know what you call this gear. That's the worm gear, and I guess this could be a spur gear too for the diff. And I'm sure this is where the problem is. In fact, if I zoom in real close on some of these teeth, it even looks like there might be some wear. And you've seen the entire amount of driving that I've done, but you see this edge here that is shining? Well, that's sort of a wear mark. And I was also kind of putting these together to see how well they mesh, and it's not very good, to be honest. Well, it's not too bad if I angle it, but all of this could be better with a little bit of grease. And I may, before I even put the axle halves back on, put this diff together, see if it's moving freely, and then just spin it for a while with the drill to get these pieces to like each other a little better. But I'm going to put grease in it before I do anything else with it, because when you have a problem like that, a little bit of grease sometimes can go a long way to help solve it. This is the guts of the portal, and they're nice metal gears. I'm happy to see that. Still bushings everywhere, so I'll grease all those before I continue, and I'll just put it back together how it is, and not worry about bearings at the moment because I don't have any to put in there. This joint is really stiff, and it has nothing to do with the axle cup going in there, but I'm going to grease all that. There's a bearing or a bushing in there that I'm going to grease. I'm going to grease this one as well, and then the gears. For a while I could not figure out where that resistance is coming from, because screws aren't in too tight, the holes are big enough, and I'm just like, where's it coming from? It's not coming from that ball and socket joint in there. I just figured it out when they pointlessly added this metal piece that could have just as easily been plastic. It gets in to the top of the C-hub. You can actually see there's no distance at all between that little screw and the C-hub. So the only way to fix it is to grind away at the C-hub a little bit just to clearance that, and then it should move freely. There's lots of meat there. Don't be afraid to get into it a little bit. Alright, you see how we've got a sharp edge here? That's fine, nothing's going to get into that. But I have deeply rounded this off here. And rounded corners are great. Anytime you have parts that move past each other, it just helps them. When you have sharp edges, things catch, things can scissor and bind, and none of that is good. So why not just start rounding corners off at the factory? And you'll see here that in order to make this work, I've had to cut pretty deep into the back of this, because at full steering lock, it's those little screws from the top are still getting into it. So I'll clean up some of this flashing on it and put it back together for you. And I think it's going to move freely this time. Well, even by taking off all that, the screws don't hit anymore, but now the actual silver part is getting into that. When it turns, you can see it hitting that C-arm. So I'm going to taper that metal piece a little bit. Ladies and gentlemen, that is how a steering knuckle is supposed to work. Unless it works like that, you're going to lose servos a lot. And this is the other side now. I had to do a little more cutting on this side for some reason, not sure why, but this screw here really gets into this C-arm. And had that been triangulated, which is what I basically did to it, there would have been no issues. And probably a lot of the servo problems I've had, servo failures, would not even have occurred, because every time that thing has to turn the wheel, it was fighting the C-hubs. So by doing this, effectively, I've made the servo stronger, because it no longer has to deliver force to push this through something that it shouldn't have to push through. So I don't know. Or you could just drive your truck until it blows up, replace your parts. They all blow up eventually, but that's pretty much how I did it right there. Just kind of scooped it out until it was free. All that's left to do is reinsert the axles properly. And I'll do that all off camera. It's a little bit hard to fiddle around with it like this. When I did not have these 4 screws in that hold the axle together, it moved freely. Now that I've put them back together, it's tight again. Everything is bound. And I'm not sure how I'm going to fix that yet, because it's just how it should be, and yet it's so tight that nothing moves now. It's put pressure all through the drive shafts, through the axles, clear to the outer hub that's made these solid again. You saw them both move. And that right there is where that springing, I can feel it in the gear here. I'll zoom in on it and see if you can actually see that move when I. No, you can't see it, but you can feel it. I feel that whole gear moving forward towards my hand. Maybe you can see it there. And the light. All right. There you can see it. See that bumping out? The actual drive shafts are causing the problem. They're a little bit too long. It's not going to take much, but I'll have to figure out where I can take some length out of them. Well, I'm trying to get as much drag as I can out of the system, so I went and I took all the grease out and cleaned it real well, and then I put this 3-in-1 dry lube in that I like a lot for my gears because it doesn't draw dust. Another reason is this is not a sealed portal. That dot right there that you can see in the back right there, don't drive this in water or you'll flood your gears. So no point in putting grease in something like this. So sorry I wasted your time with that, but 3-in-1 works just as good, but has no drag, and I just want to be able to prove that the axles are literally too wide, and they're putting so much force against this that it's binding everything up. It's what I'm probably going to end up doing is try to get this so you can see it, tapering that edge back farther, and then on both sides, and then just shortening the end a little bit, and hopefully that'll give it that extra tolerance that it needs. There's no reason for tight tolerances on a crawler. There just isn't. Not like this. So when they're too tight, all you can do is start taking metal out. Crawlers can be loose. Alright, here's what we're facing. See how that rocks? That's actually pivoting on the drive shaft because it's just a little too long. So if I push it, you can see the gap there. And it'll literally have to take out a fraction of a millimeter, and these things will be free. But until I do, it's not going to do it. So I think what I'm going to do here is shave back this a little bit on both sides, and then just kind of take the end of it off a little bit. And I'm going to try to not touch the machined section that you see here. I don't want to touch this part at all. I just want to cut into that part there, and because I still want this surface to match right onto that gear. But if I can shave this back a bit on both sides, I may just be able to shorten one side or the other, and it will get rid of that cross pressure for when you shove these two axles together through the gear. It's just too much for it. I mean, I probably could shave the sides of the gear, but I don't want to do that because I don't want the gear to end up wobbling. But you can see it spins freely when it's not having pressure forced in from the side. Putting them together is just too much. I have done everything on this thing to get it right. I've shortened the axles a little bit so they no longer push out hard enough to stop the motion, and for the most part anyway. And everything is free. The portals are free. Everything's free. I hate these bushings. They're terrible. But the worst part is I'm coming to the conclusion that this gear here and the diff just may not be cut right. I don't know why it's so much bigger around than the SCX24 ones, which work perfectly in the same exact housing because I can put an SCX24 diff cover on it. So I am frustrated at this point. I don't know how I'm going to make this happen, but I think what I'm going to do is just put a drill on this and spin it until it runs free, because I literally don't know what else to do at this point. That gear just does not want to turn. Alright, I've got the axle pretty much nailed down now. You remember how I showed you the wobble in the pinion gear on the motor? I have a suspicion that the gear on the main center gear, that gold one on the axle, is also wobbling, perhaps, potentially. And back to this, what I've done is a mini Z trick where I made this so it can now move, and it's free moving. This one is what's stopping that articulation. That is just stiff. See how it pops? Doesn't move freely. It literally stays in position. Where this one will actually pivot and move. And this is what you need. if you want that suspension to articulate, it has to be free to move. And here's how to fix it. Rip that out and put it in your drill. I haven't put the motor back on, but I've got the front suspension back together minus the shocks, just because I wanted to show you something that now that it's free, this thing has quite a bit of articulation. See that? And more importantly, I took the ears off of those ball joints there. Look how they can pivot now. They can actually roll back and forth. That's what a ball joint is supposed to do. It's not a hinge. It's a swivel that can swivel in any direction. It can swivel and pivot. So that's how that's supposed to look. I still don't have this differential how I want it, but I'm limited by the gear inside of it. That's unfortunate, but as they say, it is what it is. So I think before I really put this much more together, I'm going to change that, actually this left side arm here, and low clearance it to get it away from the motor, so that when I put it back together, I don't ever have to deal with it again. I take it apart once. This is how I'm going to bend and stretch that link. I take the ball joints out and the pivot balls, I nail it down, then I wrap it with tin foil where I don't want the plastic getting hot, and that way when I bend it and stretch it, the link stays the same length, but it gets the new shape that I really want. So if you do this, just make sure that you cover everything you don't want to bend. And I'm going to heat this slowly, and it'll go from looking kind of like a semi-matte black to wet in 1 second. That's when you have to pull the heat. And take care of the ends. I literally have one of these links. I can't mess it up. It's one of the things that's bad about these so far, that I have one and I don't have extra parts. If it was an SCX-24, I've got tons of parts. I could almost build another one from the parts I have. So anyway, I'm going to heat this up. Once it's hot, I'm going to stretch it, just bend the thing out, and then let it cool bent, and then with that bend in it, it should clear the motor a lot better, if not completely. Alright, it's got a pretty decent bend in it now. Hopefully that'll clear the motor. I'll just unwrap it, and it's still the same length. I had it nailed down, so it has bent and stretched at the same time. Also, just for fun, let's see what's inside of an oil-filled shock. It's wet, and it's got a ring like a 10th scale. I don't actually see oil in it. It's just wet. So, there's your oil-filled shocks, everybody. I'm going to say something now that is opinion only, but when you have the shock and the control link on the same screw, to me that is toy grade. Let's see what's in the other front shock. It's barely wet. Once again, there is not any fluid in the fluid-filled shocks. And I'm going to make this end also conical, since I have it off. That's right. I just want a little taper coming in from both ends. And then it will pivot a little bit. Doesn't need much, but it should have some. Alright, that's ready to go back on. This is about as close to in phase as I can get it. There's only 4 options for alignment on the drive shaft, so that'll have to do. The screw holes are slightly off, but that's the closest. As I was putting this back together, the end of the drive shaft fell out, and it uses this little pin system, and it goes on this here, and then you have a rubber band that holds that in. I wish they'd come up with a better thing than this. This is my least favorite thing I have ever seen for a drive shaft. So I got the pin in, and now you put the rubber band on the whole thing, and it's supposed to hold that pin in place. That's fantastic. I can tell you now that this will be my only T24. And I'll probably keep this one just because it's so weird. And I've had to do so much work on it to get it to basically do anything. And that main gear inside of here, the big goldish one, I need a new one. That's not right. That gear is why this whole front axle, one of the reasons why it doesn't want to do anything right. Man, that's stiff. There should be no resistance when turning that. I'm going to start sounding unfriendly in my videos by the end of this one, and I apologize. It's just that I've worked on this thing more than cars that I have actually built from scratch. So, alright, that is finally back together. I just have to put the back drive shaft in and screw it together. I was told that the output shaft on this motor is a 2mm, and if I had a hot racing spur gear, I would just get rid of both of these gears right now. The hot racing gear would give it a lot lower gear ratio, which is fine, but because of the way this pinion rotates, I have to use this gear because when it goes off center, it would skip on a SCX24 gear, which literally has 1 tooth less, by the way. So I'm going to put it back together and attempt to drive it at some point here. We've been on a journey with this thing, and it's back together. It is in no way right because that front diff has one spot where the gear binds. It's that main gear. I would like to have a nice new gear that is machined properly, but this is how it runs with its own ESC. I'm going to throw the axial one back in and just hang it on the side here and see if it's any better with that one. Let's rip that out for there. Put that in the motor. Pull that out. Put that in the battery. Turn that on. And we'll see if we don't have a little bit smoother action with it. Yeah, it is smoother. It's Still has that hang up spot. I wish I knew how to. I might take that gear out and just file on it and make it track right, because that's annoying. I shouldn't have to do that in the first place, but it's crawlable now. The motor's not buzzing, so that's good. I'm not overloading it anyway. I'm sure it's not how it wants to be, but it is crawlable. Alright, I'm going to take this one back out and run this with its own ESC, and I do have full articulation. It's free in my front shocks now. I'm super excited about that. That took a lot of work. I have low clearanced that upper suspension link to drop down where it will not hit the motor. You can see the bend in it there. It is that link right there, and I just dropped it out of the way. It gets close to the lower link, but it does not touch it at any point. I'm kind of a little bit worried about that, but that can never hit the motor. So at this point, I am going to call this the most correct Panda Tetra 24 X3 or whatever they call it, because everything moves except for that front diff the way it's supposed to. Once you get the front steering knuckles, the C-hubs free, it has pretty fast steering. I'm surprised by that. And that servo doesn't sound like it's working hard, but that's actually really fast steering. It's not bad when things work the way they're supposed to. I've had a chance to drive this a little bit, sort of get the feel for it, and I'm just going to show you how it does the stairs here, which you've seen on my channel many times. It has plenty of body rub in the tires. You are witnessing as far as I've got it so far. I just blew it. Well, that was actually as far as this has been able to drive in that last shot. It has no power compared to an SCX24. It's very little torque. It is very top heavy compared to an SCX24. I think the tires might actually be decent. That sound you're hearing is the tires actually rubbing on the body. I think they should have, well, they can't. I was going to say they should have put some smaller tires on it, but in order to clear the portals, you got to use a big tire, bigger than a 1.0 rim, just to get it in there. This is full throttle. I'm going to do one more thing just to convince you of something. And since these two rigs hit the same price point at about $140, I thought I would show you what you're getting for your money. And this will be just a little drag race. Are you ready? It's not even close. I gave the jump to, gave the hit actually to the Panda, and the SCX24 outran it. Well, I've shown you the guts of this thing. I've shown you how to make the suspension work. I actually put the stock springs back on the front, and wouldn't you know, once the control links are free, it actually gets full suspension travel, and I'd say they're right. I mean, they get tight right at the end, right as the springs bottom out, and front and back shocks fully articulate now. You do have to conical shape those with a razor knife like I showed you to get that full motion. Otherwise, these are hinge and they won't pivot. They need to pivot in order to get that. The low linking really did a nice job getting rid of the motor hitting. It still hits here, the servo, onto this top piece. We knew that was going to happen. There's no way around it. If you want to keep these two body or what do you call them, magnet connections and body mounts, but maybe there'll be a way to lower that a little more. I don't know. It doesn't really matter to me. This thing is slow compared to the SCX24s. It has no torque compared to the SCX24s. It's very top heavy compared to the SCX24, and it is the same price. So if you want to go really slow and have blinky lights, it is a beautiful truck for you. I'll just say it's not for me. If you want to drive it, that's fine. I will say there is one thing in this kit that is pretty nice right out of the kit, and I really like it. It's this wrench. That thing is shiny and beautiful, and I just like that. Anyway,